Hello, I'm Rafael Leal. I work at the bank for almost 4 years now. I'm a lead software engineer at the CSD team, and we're going to present you how the bank scaled its CSD platform. I'm here with Alan Gilardi.
Hello, people. Thank you so much for having us. My name is Alan Gilardi. I'm a staff software engineer here at Nubank. I joined the company almost 6 years ago. And let's tell you a little bit about our experience with Tecton, how we scaled up our CSD process to support millions of builds, and how Tecton plays a crucial role in this process. So just before jumping into the interesting parts, let's talk briefly about Nubank if you don't know us. So essentially, Nubank is a fintech, a financial institution that was born here in Brazil in 2013 with a very ambitious mission of being the most influential fintech in the world. We started out with a single product, a credit card, operating just here in Brazil. And a few years later, now we are operating in 3 different countries. We provide a wide variety of financial products. And recently, we got to the impressive mark of 7 million of customers. And let's take a look at how this accelerated growth can be reflected in our engineering numbers with Rafael.
So how that massive scale translates to engineering. Nubank has over 1,500 engineers. It does over 1,000 deploys per week, manages over 3,000 Git repositories. We have over 40 Kubernetes clusters. And in terms of CI/CD, we run about 2 million task runs per month and process 680,000 GitHub events per month. And this scale is not only important how big this is, but how we got there. So in this graph, you can see the number of task runs per week between October 2020 and October 2022. And you can see that in October 2020, we had less than 20,000 task runs per week. We reached a maximum on August 2022 with 500,000. And we are sitting around 400,000 and below. Before talking about these challenges of growing that fast and managing a CI/CD cluster that big, I'm going to take a step back and look at what we had before 2020 and how Nubank does CI/CD before all that. So in the past, we had an on-premise legacy CI/CD system, the GoCD, and GoCD works with a master worker model. So that was giving us a high operational burden because we had to manage over 300 EC2 instances in AWS, and we had a single point of failure on the master node. The master node not only had to orchestrate that many instances, but there's other processes very important, like providing the UI and doing backups and so on. That was leading to long queues and instabilities. We had, since the instance was attached to the AWS roles, we had a poor policy segregation. We had a trade-off between having more operational burden and following the least privilege principle. And even with all that operational burden, we couldn't support all use cases for Nubank. GoCD doesn't have a good support for pull request workflows, so we started using a software as a service for that. Also, MonoHypos, we had a different solution for that. And we really wanted to have a canonical approach for CI/CD. Now, Alan's going to talk a little bit about that.
Great. So back to 2019, we were struggling a lot to keep our CI/CD operations minimally functional. And it was quite clear for us that we would need to change dramatically the status quo. And we started doing this move by creating a dedicated team for managing the continuous delivery, the continuous integration delivery process inside the company. And it was definitely one of the most important decisions that we made in the past, because this enabled us to start treating CI/CD as a first-class citizen. Continuous integration and delivery plays a crucial role inside the company by enabling people to deliver software faster and safely to production. And it makes totally sense for us to treat CI/CD as a domain, as something that could be understood with a value by itself. It's quite curious because typically CI/CD or companies tend to treat CI/CD merely as a mean of achieving something else instead of being a value by itself. And not merely the CI/CD process ends up being a bunch of ugly bash scripts spread across multiple repositories, and things tend to become a mess over the time. And we decided to change this approach and to build a solid product vision over our CI/CD platform. So let's move on. And just before getting to Tekton, it's worth answering this question. Why exactly we decided to use Kubernetes? Well, we were looking for a solution that could help us to scale over time, to absorb high demands, high loads, and also to be cost efficient. The idea was having a platform that could scale to be adaptable to periods of high peaks, and also to be smart efficient enough to deal with periods of low usage. And Kubernetes came out as the natural solution for that, because Kubernetes already solves handsomely this kind of problem that we were facing. Kubernetes is the standard for containerization. It has a robust and very mature ecosystem of multiple applications around it. Kubernetes integrates nicely with Prometheus and other monitoring tools. And as I said before, we'd like to treat CI/CD as a domain, and we really like to apply the same quality, the same standards that we apply to other software products or other products inside of the company. And for sure that observability, gathering data for making more accurate decisions is part of this philosophy. And finally, Kubernetes is quite flexible. It provides custom resource definitions that we can leverage for modeling or creating abstractions that can represent our domain well. So since the beginning, we knew that we'd like to build a few abstractions on top of our CI/CD platform. Okay, so let's move on and let's get to Tekton finally, Rafael.
So we knew that we wanted to move to Kubernetes, but we didn't know exactly how, and we started to look to alternatives, and we found this presentation about Tekton and GKA, trying to show you how next generation of CI/CD looks like, and really caught our attention because it was Kubernetes native. We ran some proof of concepts, and it really solved our issues with policy segregations, and really had good building blocks for us to build a very scalable platform. Of course, having new platforms doesn't mean that we're gonna stop having challenges. We're gonna have a bunch of challenges, and I'm gonna try to show you some of those challenges, starting with garbage collection.
Let's talk about the challenge for running Tekton in massive scale. Garbage collection. We realized very quickly that accumulating a large number of objects inside a Kubernetes cluster would not be a good idea, because it puts extra pressure over the etcd and consequently over the API server. So we had a couple of incidents where, due to the large number of objects inside the Kubernetes cluster, the whole system started to degrade in terms of performance. So we experienced long queues, increasing latency, and so on. So we developed a custom garbage collection mechanism for deleting completed runs. And then by doing this, we observed that the performance of the cluster improved, and this enabled us to have a more dynamic cluster in terms of scheduling more, a great number of simultaneous task runs. of course, that once we start deleting things, we lose history, and history is something crucial for a CI/CD platform, not only for providing data for people that want to debug runs, but also we are in a financial area where audit process is something quite common and necessary. So having some way of having this data persisted for analyzing later was crucial for us. We developed the mechanism for persisting the data of the runs into our data lake to be consumed later. And finally, logs. Once we delete the test run, we end up deleting the underlying pod, and also the logs go away. So we created also a custom mechanism for collecting logs and sending them to a persistent storage to be served back later to our users. So and it's worth mentioning that those things were developed before the Tecton Results project came out. Okay, so let's move on. Let's talk about Parafinite Assistant. In our case, we decided to disable the Parafinite Assistant entirely because since it forces task runs that share the same workspace to be scheduled to the same nodes in massive scale, reminding that we are talking about thousands of simultaneous runs. We observed long queues. We have some repositories with a very high churn in terms of contribution. So we decided to move to a different approach. In our case, we use a network file system, EFS, because we run our platform on AWS. And EFS, this network file system can be mapped to a read-write many person volume. So this helps us to attach this volume dynamically to nodes without caring about doing this manually. And this helped us a lot to have a more elastic cluster. We use an external system that provisions nodes according to the resources that are assigned to test runs. And with this approach, we got to a more dynamic, more elastic cluster where nodes go up and go down according to the demands. You can see through this chart that the number of nodes in the Kubernetes cluster varies a lot according to the demands. So let's move on. Finally, high availability, it's certainly another important aspect in terms of running things in massive scale. We observe it under a certain periods of high peaks that the Tecton's controller was getting extremely overloaded with a large number of keys to be processed in its work queue. And we were experiencing, again, long queues, high latence to schedule new runs. And we decided to scale up the Tecton's controller vertically and horizontally. Vertically by assigning more Google Teams, more workers to consume the keys from the Tecton's work queue. And horizontally by relying on the excellent leader election support provided by Knative, where we can have multiple active replicas that will shard the keys among them. So we use this extensively. Currently, we have 5 active replicas running. This helped us a lot to deal with these challenges. So let's move on to talk about vendor limits, Rafael.
Well, with all this new platform, we removed most of the bottlenecks, but we started to reveal other bottlenecks. We started to have issues with rate limits on GitHub, and we've really built our platform around GitHub to provide feedback for our users. So that was really key for us. We also had issues with Kubernetes API server latency, etcd, and part of our network infrastructure. When you're running that many concurrent tasks, you're gonna have to provision your network accordingly, and we started to have challenges on that as well. And to address this, it was clear for us that we needed some control of how many concurrent tasks we run in our cluster. We couldn't just trigger pipeline runs every time that an event came. So we decided to implement an execution queue outside Kubernetes And it's important that's outside Kubernetes, because Kubernetes is part of the system too. So having this on, we used AWS SQS that enabled us to observe metrics on our Kubernetes and decide if you're going to run that or delay that execution. Why I built this whole framework? This framework is about scalability, but it's also about having more usability for our users. So really wanted to have autonomy for a very diverse team that we have in the bank to develop and maintain their pipelines. We wanted to have high-level abstractions and improve the development experience. We also didn't want to lose control over some canonical approaches, since you have a very uniform architecture. And we've built on this abstraction to really remove the complexity of maintaining pipelines. So now I'm going to show you a bit about this platform. In this demo, I'm going to show you how to create and run workflows. We're going to use this repository that has a very simple Golang test. The first thing we need to do is to create a folder .new/workflows. This depends on the installation and it's configurable. We can create a file pr.yaml, and since we are defining a workflow manifest, we're going to start with API version workflows.dev/v1 alpha1, then the kind, metadata. Here we don't need to fill the name field. We can define only the namespace, since the name is going to be automatically generated based on the file name. Then we have the spec. The first thing I want to do is to define when this workflow is going to be triggered. We're starting with events, push, then branches. I'm going to run on all branches except main branch, since this is a PR check workflow. Now I'm going to define the tasks. We're going to define a very simple unit task. And here we can define the steps. The first step is a special step that clones the repository. Then we can run go test /. You can also define names for these steps. And now we need to define the image that we're going to use. We can define it inside the step, but we can also define a default image for all the workflow. So we can define defaults image. Here I'm going to use an internal image from ECR. Now our manifest is ready and we can commit and push to the repository. I'm going to open a branch, git checkout, add new workflow, add new PR, commit, add new workflow, git push. Now we create our pull request. We can see that we already have one check, letting us know that the workflow is all set. This means that the workflow is already configured in our cluster, and we can check with kubectl, get workflows, and we can use the label to filter by repository. This also means that all the dependencies from that workflow was also created. So For example, we have a CRD called deploy keys that manages the SSH keys for the repository. And here we go. So now the workflow is ready to trigger in the next push. So I'm going to create an empty commit, git commit, allow empty, trigger workflow, git push. You can see that the task is already created. We can click on the tails. It's waiting to start. Now it's done. You can check the tails of the task here. Events, results, and the rendered task spec. You can also click on any task at any step here and get the logs for that step. Here in the log, we can also enable timestamps and download the log. That's it for this demo, and thank you.
Finally, people, next steps. So currently, we are working hard for designing a consistent sharded architecture for our CI/CD platform, because even after all of those things that we mentioned over this presentation, we are still growing fast, quickly. And we are reaching to certain limits, mostly in terms of storage of etcd. We have projections telling us that we go there to those hard limits in the beginning of the next year. So we are trying to anticipate things and design a sharded architecture. Of course, the objective is having multiple clusters, sharing loads, but also providing this in a seamless way for our users. Hopefully, this design will be captured somehow in our framework. We are also working for open sourcing our platform. This is something that we'd like to do soon. We strongly believe that we solved a few problems that can, that the community in general could take advantage of the things that we've built. Most likely other companies running into the same issues as we are could leverage the things that we developed in a very good way. So hopefully soon we're gonna have news about this. And finally, just to mention that recently we got closer to the Tectons community. We joined some interesting discussions about some features. Rafael joined the working group for building a workflows engine for Tecton recently. I have been working actively, contributing actively to the Tectons Result project. I think that's quite promising. Certainly, there are many features that this project can provide to help us to solve some challenges that we are facing. And hopefully, this contribution will keep going and growing over the time. Okay, people, that's it for today. Thank you so much for having us.
Thank you. If you have any questions, feel free to reach us.